for the last one here, you got a population of a certain city experiences exponential growth. If at the beginning of 2000, the population is 75,000, and 6 years later, the population is 100,000, how long will it take for the population to double? So there's a couple ways you can do this. You could either use the exponential growth E function, P equals E to the RT, or you can use doubling time. And I'm going to go ahead and use the doubling time. And the doubling time formula says your the amount of your population. I'm just going to use P here. I think we use N in the book that we had, but our population is going to grow at some beginning point P times 2 to the T over the doubling time. And so in this equation here, what we don't know is what the doubling time is, how long the doubling time is. But we do know each of these other three things based on the scenario given to us, right? We know we're going to have, after 6 years, we're going to have 100,000 people. We started with 75,000 people, and that's going to give us 2 to the 6 over D. So we can divide this by 75,000. That just ends up being 4/3. Equals 2 to the 6D. And now we just need to solve this. And there are various ways that you can solve this. It's just going to be using logarithms and somehow or another. I'm just going to use log base 10 to make my life a little bit easier for typing it into a calculator. You could also do log base 2 if you would like. That would be perfectly fine. So I take the log of both sides. And so that gives me log of 4/3 equals log of 2 to the 6 over D. Remember, that means that can go out front, and so we get log of 4/3 equals 6 over D times log of 2. So bring the D over here, divide by the log of 4/3, and we get D just is going to equal 6 log of 2 all over log of 4/3. And so now we can type that into our calculator and say 6 log of 2 divided by log of 4 divided by 3. And that gives us the doubling time is 14.456 years. And so we just rounded to the nearest 100. So 14.46 years is what the doubling time would be for this population. Now, like I said, you could have done E as well. And so if you thought to do E, what you would do is you'd say P equals P not E R E to the RT. And remember, R represents your unit time, which is going to be years, continuous growth. And so we do the same thing we did. We say 100,000 equals 75,000 E to the R and times 6. And so that allows us to calculate. And so the nice thing about this one is because of the natural log, it's a little bit easier. You do the natural log of both sides, and you get, because the natural log of E to the 6R just equals 6R. And so R equals natural log of 4/3 over 6. And so we can calculate that. And so we do the natural log of 4 divided by 3 all over 6. And that gives us a growth rate of continuous growth rate of 0.479470121. Well, it said, how long will it take for the population to double? That means we need to rework our equation and say we need to find out how long does it take. And you could do it as, 150,000 equals 75,000, or you could just realize, wait a second, that's just like a 2-to-1 ratio, which is all that really matters. And then you just solve this equation, or R being what we just calculated it to be. So divide by 75,000, you get 2 equals E to this RT. When we take the natural log of both sides, we get the natural log of 2 equals this times T. So we just divide natural log of 2 divided by our answer, the 0.40749, and we get the same 14.46 answer. And so either one of those are good ways to do that problem. It doesn't matter which one you do. Both are effective and tell us interesting, good information.